Hello students, welcome back to the channel. Today's topic that we are going to discuss is about the eigenvalue and the eigenvector. Before going to the eigenvalue and eigenvector, it is very important to know how to solve for the characteristic equations, which is of A minus lambda I form. And this topic is very important as this is like a base or the step one in order to solve for the SVTs and the diagonalization. So without any further delay, let us see how we can solve for the 2 cross 2 and the 3 cross 3 matrices. And this is a shortcut method. You can use any method you like. Okay, so the shortcut method, so please remember this might be a time saving thing for you in the exam. So the formula will be for 2 cross 2 always starts with a lambda square minus it's plus minus plus minus, please remember. So minus trace of a that is a matrix into lambda square, after that lambda plus the constant, that is determinant of A is equal to 0. Now let me take one example so that it is clear to you how to form the equation using the formula. So the matrix will be 1 4 2 3. How to find the trace? Trace is nothing but the addition of the diagonal, right? It is nothing but 1 plus 3, which is equal to 4. Now if I want to find the determinant of A, it is nothing but it is 1 into 3 3, that is 3 minus 4 2s are 8, right? Minus 8. Okay, so I will get the answer as minus 5. Now let me substitute back into the, we got all the unknowns, let me substitute back. So lambda square minus 4 into lambda plus so it is plus of minus is minus, right? So it will be minus 5. One second, it's minus 5 is equal to 0. So we all know how to factorize this. We have been taught in our the 5th or 7th grade, so we know how to factor. Or you can use your scientific calculator to get the values of the lambda 1 and lambda 2. So we got the characteristic equation. Now let us see for the 3 cross 3 matrix. It always starts with lambda cube minus trace of A lambda square. Here one more addition, that is sum of the minor along the diagonal, sum of the minor along the diagonal into lambda plus minus determinant of A is equal to 0. Okay, now let us take one example with the 3 cross 3 matrix, say 1 0 2 0 2 1 2 0 3. Now we know how to take the trace of the matrix A is nothing but it is the addition of the diagonal, which is 1 plus 2 plus 3, which is 6. Now the main thing is we have to find the minor, that is M11. That means what you have, M11, M22 and M33. These three we have to find out. What we have to do, we have to eliminate the first row and the first column, right? First row and the first column. So let me mark it so that you will understand first row and first column, and whatever the left terms are there, we have to take the minor, that is 2 into 3 6 minus 0 into 1 is 0, that is 6. Now M22 is like this, right? So second row and second column, right? It's 1 2 1 3, 1 into 3 is 3 minus 2 into 2 is 4, it is minus 1. Now same way M33. So what we are eliminating, it is third row and third column, right? It is 1 0 0 2, right? It's 1 into 2 2 minus 0 is 2. So we have to find the sum of this. Now let us substitute back and one more thing is determinant. So when you find the determinant of A, you will get the answer as say maybe, let me find out. So it is nothing but 1 into 6 minus 0 plus 0 into 0 plus 2 into 0 minus 4. So I will get the answer as minus 2. Alright, so now let us see the let's substitute. It's lambda cube minus 6 lambda square plus what will get 6 minus 1 plus 2 into lambda, that is minus of minus 2 into, it's equal to 0. So 6 lambda square plus 7 lambda plus 2 is equal to 0. So this is the way how you are finding the characteristic equation, and through this you can find the lambda 1 lambda 2 lambda 3. I need the answer in the comment box. You can leave the answer in the comment box. You can use a scientific calculator and find out how to find using the scientific calculator. Now without any further delay, let's dive into the eigenvalue and the eigenvectors. So when I say the eigenvalues, so let me write it down, eigenvalue and eigenvector. So eigenvector. So probable question in the exam, find out the eigenvalue and the eigenvector for the given matrix. So let us take one example of a 3 cross 3 matrix where A is given as 8 minus 6 2 6 minus 6 7 minus 4 2 minus 4 and 3. What is the first and foremost thing? We have to know that we have to use two formulas here. The first one is A minus lambda I, which is nothing but your characteristic equation, and second one is A minus lambda I into x is equal to 0 for the eigenvector. Okay, so the first for eigenvalue, second for the eigenvector. So first step one is finding out let me write it down, finding characteristic equation using A minus lambda I. Characteristic equation using A minus lambda I. So what is A minus lambda I? So A minus lambda I is nothing but, we know what is A, right? That is a matrix A, minus 6 2 minus 6 7 minus 4 2 minus 4 3 minus lambda into 1 0 0 0 1 0 0 0 1. So what we'll get, it is nothing but 8 minus 6 to multiply lambda to the identity matrix. So minus 4 3, you will get minus lambda 0 0 0 lambda 0 0 0 lambda. Now subtract two matrices, so you will get 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda. Now you can do one thing, that you can expand using the first row and you can form the equations. You can do the expansion and you can do it, but it is very time consuming technique. So what I will do is, I'll pause it here. Till here the steps are, you have to write it down in the exam, okay, no matter what. But from here what I will do is, I know the formula for the 3 cross 3 matrix. What is that? Lambda cube, right? Lambda cube minus trace of A into lambda square plus the sum along the diagonal, right? Sum of the minor along the diagonal into lambda, diagonal into lambda minus determinant of A is equal to 0. So we are not using the above from the matrix, we are using the A matrix itself, right? We can't use the A minus lambda 1, right? So we are using this and we are getting the, directly we'll try to get the answer. So what is that? 8 plus 7 plus 3 plus, we are finding the minus. So what is minor? 7 into 3 minus of minus 4 into minus 4, so you will get 21 minus 16 is equal to 5. Now m2 is what? We are eliminating second row second column, right? It is 8 into 3 minus 2 into 2, right? 2 into 2. So what is that? 8 3s are 24 minus 4 is equal to 20. Now m33, third row and third column we are eliminating. So 8 minus 7, so 8 into 7 is what? 8 into 7 minus of 6 into minus 6, it is 56 minus 36 is equal to 20. So now substitute back into lambda minus determinant of A. So what is determinant of A? So when you find out determinant of A, you will get the answer as 0. You can use your scientific calculator, substitute whatever the unknowns are there into the equation. So you will get the answer as like this: 45 lambda minus 0 is equal to 0. 18 cube minus 18 lambda square plus 45 lambda is equal to 0. So when you find out the lambdas, you will get lambda 1 is equal to 2 0, lambda 2 3, lambda 3 15. So these are called as the eigenvalue for the given matrix. Now using this eigenvalue, we have to find the eigenvectors. Okay, eigenvectors. So the formula for eigenvector is what? A minus lambda I x into x is equal to 0. So what we can do, we know what is A minus lambda I, right? What is A minus lambda? So case 1 for when lambda 1 is equal to 0, we have to find the eigenvector. So A minus lambda I is what? We know that what? It is nothing but 8 minus lambda minus 6 2, right? Minus 6 minus 7 minus lambda minus 4 2 minus 4 and the 3 minus lambda. What extra we have to do? We have to place that x, right, is equal to 0. So same equation we are writing as 8 minus lambda minus, let me write the matrix first. 8 minus lambda minus 6 2 minus 6 minus 7 minus lambda minus 4 2 minus 4 3 minus lambda into x1 x2 x3, right? We have three unknowns here now. X1 x2, that is itself is a eigenvector, is equal to 0 0 0. Now what we have to do is we have to substitute the lambda value to the given the matrix, that is 8 minus 0. So you will get the same matrix. Please write it down. So 3 minus 0 is 0, sorry 3, and x1 x2 x3 is equal to 0 0 0. Now our main motive is to find the values of x1 x2 x3. Okay, what is the value of x1, what is the value of x2, what is the value of x3? This one we have to find. So we have our technique called as a Kram's rule. So what we can do with the Kram's rule is that you hold any of the any of the first column or the first row as a constant, and we will write it. So x1 will be what? You eliminate the first row and the first column, so you'll get the whatever the remaining element, uska determinant you have to find, that is 7 minus 4 minus 4 3 minus x2. Okay, it's plus minus plus again. So write down again the first row and the second column you have to eliminate. So what you will get, that's determinant. Again the third, the first row and the third column you have to eliminate. So write it down. So it is minus 6 7 minus 2 minus 4. Now it is very easy to find the determinant. What is x1 value? X1 is nothing but you will get the value as 5 minus x2. You have to find the determinant. I am writing it directly. So you when you find the determinant, you will get the value. So I will take 5 as common. So it is 1 2 6 3 is equal to 2. So what is the value of for lambda 1 is equal to 0? What the value will get? We'll get x1 x2 x3 as it is 1 2 2. 1 minus 2 2. So sorry, here please that it's minus is there in the x2, so it's minus 2. All right, now let's see for lambda is equal to 3 how we are going to do it. Directly what you have to do, a minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda into x1 x2 x3 into is equal to 0 0 0, right? Now what we have to do, we have to apply the value of 3 in the place of lambda. So what we'll get, 7 minus 3 minus 4 2 minus 4 3 minus 3 3 minus 3 x1 x2 x3 is equal to 0 0 0, right? 0 0 0. Now we'll solve for it. So I'll get 5 minus 6 2 minus 6 4 and minus 4 2 minus 4 and 0. So x1 x2 x3. Now again we are repeating the same step by using the Kram's method, holding the first row as the constant, and x1 will be what? The leftover eliminants, and finding the determinant of that. Okay, is equal to minus x2. Again the first row and the second column will be eliminated, and whatever the remaining terms we have to write. Similarly for the the first row and the third column will be eliminated. Now what is the value? x1 is equal to minus 16, x2 minus x2 is equal to 8, and x3 is what? x3 is, you will get 16. So when I find I can take the common term out. So it is minus 2 is equal to minus x2 is equal to 1 is equal to x3 divided by 2. So I got the value for the lambda when lambda when lambda is equal to 3, lambda 2 is equal to 3, I got the eigenvector as say minus 2 minus 1 and 2. Okay, now the last but not the least, we have one more lambda, that is lambda is equal to 15. So I will write directly, but everything has to be written step by step. Okay, into x is equal to 0. So I will directly substitute, and I got the answer as minus 7 minus 6 2 minus 6 minus 8 minus 4 2 4 and minus 4 and this answer will be I'm getting as minus 12 into x1 x2 x3 is equal to 0 0 0. Okay, so solve for it. I am getting the answer for x1, x2, x3 as pause the video and solve for it. So I'm getting the answer as 2 minus 2 and 1. So that is all about the eigenvalue and the eigenvectors. So we'll do the second video for eigenvectors. Please stay tuned for